National 5 biologists, let's do this past paper question together. So this one says, high altitude training is an important part of athlete preparation for endurance sports such as long distance running. As altitude increases, the oxygen concentration of the air decreases. The table shows the effect of training at different altitudes on athletes' red blood cell count. Okay, so we've got the different altitudes and we've got the average red blood cell count. Okay. What we have to do in this question is we have to, on the grid, complete the vertical axis and plot a line graph to show the effect of altitude on the average red blood cell count. Okay, so first things first, we should probably label the axes here, okay? So we're going to say the average red blood cell count. And we're going to put in our units here, which is in millions per milliliter of blood. Okay, it's quite tricky writing side on here. So millimeter of blood. Okay, so we label exactly what's up here is exactly what goes on here. Okay, don't try and shorten it, don't try and abbreviate it, just write exactly what's in this heading in the table on the axes of your graph there. We're then going to look at the values. Now, the highest value here is 9.4. So we probably want a scale that goes up to 10, ideally. So if we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That works out perfectly. Okay, it's almost as though the SQA have given you the exact amount of space that you need. Okay, so we have to plot this graph. So at 0 altitude, so okay, when the altitude is 0, the average red blood cell count is 4.4. So we go up to here and we go and we place a dot there, okay, at 4.4. Now each of these small boxes is worth 0.2. We can work that out because there's 5 boxes between each whole number, and 1 divided by 5 is 0.2. Okay. The next one we've got is 5, so that's at 0.5, which is here. So it's going to be there. Then we've got 5.6, which is at 1, which is going to be here. Then we've got 6.2, that's at 2.5, so we go along to 2.5. And just be careful that you're not just going line by line, that you're actually looking at the data. 3.5 is 7.4, so we go to 3.5, and we're going up to 7.4 there, which is this one. Then 5.0, which is this, is going to be 8.8. So we go up to 8.8 for that one. And then 5.5 will be 9.4. So we go all the way up to 9.4 there, okay? And we can see a nice clear increase there, okay? A nice increase in gradient between every one of our points there. And all we'd do is we'd get a ruler and we draw a nice straight line between our points there, okay? And apologies, I'm not using a ruler, I'm just doing this for quickness, but you guys in the exam would use a ruler and just join up your points, okay? And your graph would look a little bit like this, but a bit neater. Okay, part A2, it says, describe the relationship between the altitude and the red blood cell count. So when we're describing a relationship, I always say this with these relationship questions, always start as the something increases. The other thing either increases or decreases. So in this case, it's as the altitude increases, okay, our altitude was going up. We saw, and we'll look at the graph again just to show you, we saw from our graph that as the altitude increases, the average red blood cell count also increases, okay? So the red blood cell count also increases, okay? And that's how we do a relationship question. Next one, using the information from the table, predict the average red blood cell count of an athlete training at an altitude of 3.0 kilometers. Okay, so for this one, we look at our table and we've got 2.5 and we've got 3, but we want to find out 3.0, okay? So all we do is we go halfway between these two values. Now, the difference from here to here is, what, 1.2? Okay, we divide that number by 2, which gives us 0.6, and we add that 0.6 onto 6.2, and we get 6.8. Okay, so our answer is going to be 6.8 there. Red blood cells are important for transporting oxygen. In what form is oxygen transported by the red blood cells? So the oxygen needs to combine with hemoglobin. Okay, so the oxygen and the hemoglobin combine and they form something called oxyhemoglobin. Okay, and that's the form in which it's transported. Okay, the oxygen and the hemoglobin combine together to form oxyhemoglobin. And B part 2, give one structural feature of a red blood cell that allows it to carry out its function effectively. So there's a few that you can choose from here. We can either say that it's biconcave in shape, and therefore that gives it more area, more surface area. It has no nucleus, which also increases the surface area to carry oxygen. Or you could say what we've said up here, which is that it contains hemoglobin. Okay, hemoglobin as well. Any one of those structural features would be acceptable for this one. Okay, folks, hope that's helped. I'll see you in the next one.